All right, so this is lesson 22 already. Only 3 more weeks left to the term, I guess. And we have an exam this time on Wednesday. So the exam will start at 1, be done at 3, and just like the first exam and the homework, you do the exam, make a PDF copy file of your papers, and upload it to Blackboard. That's all pretty straightforward. Okay. So problem 1 on the review sheet was a series of functions to differentiate. So the first is y equals x squared times the square root of 1 minus x squared. So dy dx, first of all, by the product rule, it's 2x times the square root of 1 minus x squared plus x squared times the derivative of the square root of 1 minus x squared, which is 1 minus x squared to the 1/2. So this is 2x square root of 1 minus x squared plus x squared. And when you differentiate, when you differentiate by the chain rule, you get 1/2, 1 minus x squared to the minus 1/2 times the derivative of 1 minus x squared, which is minus 2x. So this is 2x times the square root of 1 minus x squared minus, and these 2's cancel. So this looks like x cubed over square root of 1 minus x squared. And if you put this over a common denominator of the square root of 1 minus x squared, you get 2x times 1 minus x squared minus x cubed. So this is 2x minus 3x cubed over the square root of 1 minus x squared. Right. 2x times this plus x squared times the derivative of this, which is 1/2, this to the minus 1/2, minus 2x. Looks like it's okay. Any questions about this? Part B is the function y equals sine of 3x plus 2 cosine x. So dy dx is the derivative of this. The derivative of the sine of 3x is the cosine of 3x times 3 minus 2 times the sine of x. One C, we have the function e to the x plus 3 to the x, which is e to the x plus, and the way you differentiate 3 to the x, this is e to the log 3 times x. So the derivative with respect to x of e to the x plus 3 to the x, the derivative of e to the x is e to the x. The derivative of e to the log 3x is log 3 e to the log 3 times x, which is,
Professor,
yeah,
I can't see. Could you move the paper a bit down?
you should be able to see it now.
Yeah, I got it. Thank you.
So this is e to the x plus log 3 times 3 to the x. Any questions about that? D, we have the function tangent x over x cubed minus 1. So we differentiate using the quotient rule. You get x cubed minus 1 squared in the denominator. The derivative of the tangent is secant squared times the denominator minus the numerator times the derivative of the denominator. And that's what it is. E, we have arctangent of x squared. So what you have to remember is that the derivative of the arctangent of x is 1 over 1 plus x squared. So the derivative of the arctangent of x squared is 1 over 1 plus x squared squared times the derivative of x squared, which is 2x. So this is 2x over 1 plus x to the fourth. And finally, for the quotient 5x plus 6 over 4x plus 5, the derivative, again, we use the quotient rule, so we get 4x plus 5 squared in the denominator. The derivative of the numerator is 5 times the denominator minus the numerator times the derivative of the denominator. So we have 4x plus 5 squared in the denominator. This is 20x plus 25 minus 20x minus 24. So we get 1 over 4x plus 5 squared. So this is problem 1 on the review sheet. Right? There's the series of straightforward differentiations. Are there questions about any of these?
Professor,
Yeah, go ahead.
did you post the review sheet on Blackboard? Because I didn't see it.
The review sheet is on Blackboard along with the second sheet, which has the solutions to all the problems. And I also emailed the review sheet plus the solution sheet to everyone. So I did this just before class started, so it's definitely there now. Problem 2, we have a curve x squared plus xy plus y cubed equals 11. And we want to find dy dx by implicit differentiation. So when you differentiate with respect to x, that's the derivative of the left-hand side equal to the derivative of the right-hand side. But of course, this is a constant, so this is 0. So we get 0 equals the derivative of x squared with respect to x, which is 2x. The derivative of xy, that's, let me just write this all out carefully. So 0, just doing this term by term, is the derivative of x squared plus the derivative of xy plus the derivative with respect to x of y cubed. The derivative of x squared with respect to x is 2x. By the product rule, the derivative of xy with respect to x is the derivative of x, which is 1 times y plus x times dy dx. And the derivative of y cubed with respect to x is 3y squared dy dx. So this is 2x plus y plus x plus 3y squared dy dx. So x squared plus 3y squared x plus 3y squared dy dx is minus 2x plus y. So if you divide by the left-hand side factor, dy dx is minus 2x plus y over x plus 3y squared.
Question, Professor. Question.
Yeah, go ahead.
So what do you mean by dy dx when you were doing the product x times y?
Well, so if you have the derivative with respect to x of x times y, by the product rule, that's the derivative of x with respect to x times y plus x times the derivative of y with respect to x. This is just the product rule. But y is some function of x. That is, the whole idea is if you have a polynomial like that, the set of points in the plane that satisfy this equation is some curve. And if you take any point on the curve, there's some interval around that point where y is some function of x. So the whole purpose, the whole discussion of implicit differentiation is that a curve like this implicitly defines y as a function of x everywhere. You just don't know what it is. But there is some function y of x that satisfies this equation, and the implicit differentiation allows us to find the derivative, right? I mean, we had a whole lesson or two on implicit differentiation. It's very important.
Professor,
Yeah,
that's a minus sign?
here,
Yeah.
looks like it.
How did you get that minus sign?
Well, I have this equation, right? And I want to solve for dy dx. So I'm bringing this to the other side of the equation. So you get a minus sign.
Okay. Yeah.
Now I divide. Now, on this curve, let's go to problem 3. We're looking at the same curve, x squared plus xy plus y cubed equals 11. If you let x equal 1, y equal 2, what do we get over here? We get 1 squared plus 1 times 2 plus 2 cubed. That's 1 plus 2 plus 8, that's 11. So the point 1, 2 satisfies this equation. So it lies on the curve. So somewhere on the curve is this point 1, 2. And there's going to be a tangent line to the curve. And we want to find the equation of the tangent line. So we know a point on the tangent line because the line goes through the point 1, 2, but we need to find the slope of the line. But in the previous problem, I found dy dx. It was minus 2x plus y over x plus 3y squared. So if this is correct, if I didn't make any mistake when I calculated this, at the point 1, 2, dy dx is equal to minus 2 times 1 plus 2 over 1 plus 3 times 2 squared. that's minus 4 over 13. So this is the slope of the tangent line at the point 1, 2. So by the point slope formula, that the equation of the tangent line is y is equal to minus 4 over 13 x minus 1 plus 2, which is minus 4 over 13x plus 4 over 13 plus 2, which is plus 30 over 13. So if I was lucky enough not to make any arithmetical errors when I calculated this, this is the tangent line. At the point 1, 2, this is 4 over 13, minus 4 over 13. And this is the equation of the line passing through the point 1, 2 with slope minus 4 over 13.
Professor,
Yeah,
so what happened if the point 1, 2 doesn't lie on the curve?
well, if the point's not on the curve, there's no tangent line. This only makes sense when you have a point on the curve. There's no problem. It's like, if the problem is differentiate the following function and I don't give you a function, there's nothing to differentiate. So if the point's not on the curve, there's no tangent line to find. All right. This is problem 3 on the review sheet. Let's look at problem 4. And in problem 4, we have the following function, y equals 1 plus x cubed, 1 plus 2x squared, 1 plus 3x to the 5th. And we need to find dy dx by logarithmic differentiation. That means take the logarithm and then differentiate. So the log of y is the log of this expression, 1 plus x cubed, 1 plus 2x squared, 1 plus 3x to the 5th. So we have to use properties of the logarithm. The log of a product is the sum of the logs. So this is the log of 1 plus x cubed plus the log of 1 plus 2x squared plus the log of 1 plus 3x to the 5th. And then when we use the property that if the log of when you have the log of a power, you can bring the power in front. So this is 3 times the log of 1 plus x plus 2 times the log of 1 plus 2x plus 5 times the log of 1 plus 3x. This is all equal to the log of y. Right? So the first step is to take the logarithm of your product of powers, and this is what you get. So first of all, this has to be clear, because if you can't do the first step, you can't do the problem. Okay, so now we differentiate. The derivative with respect to x of the log of y is 1 over y dy dx by the chain rule. And that's the derivative with respect to x of everything on the right-hand side. When you differentiate the log of 1 plus x, you get 1 over 1 plus x. This is 2. The derivative of the log of 1 plus 2x is 1 over 1 plus 2x times 2. the derivative of the log of 1 plus 3x is 1 over 1 plus 3x times 3. So 1 over y dy dx is equal to this. So if you multiply through by y, dy dx is y times 3 over 1 plus x plus 4 over 1 plus 2x plus 15 over 1 plus 3x. And you can leave it like this if you like, or you can put in what the value of y is, but it's okay to stop at this point. Okay. All right. Problem 5, we have a cube. And let's say the edge of the cube is x. And we're told that the edges of the cube are expanding at a rate of 4 centimeters per second. So dx dt is 4 centimeters per second. And we want to find how is the volume changing and how is the surface area changing. So the volume of a cube of side x is x cubed. And the surface area of a cube of side x, each side has area x squared, and there's 6 sides, it's 6x squared. So dv dt, the rate of change of the volume, that's the derivative of x cubed with respect to t. By the chain rule, this is 3x squared dx dt, and dx dt is 4, and 3 times 4 is 12x squared. So that's the rate of change of the volume as a function of x, and when x is equal to 12, dv dt is 12 times 12 squared, which is 12 cubed, which might be 1,728. And the area is 6x squared. So the rate of change of the area with respect to time is the derivative with respect to time of 6x squared. By the chain rule, that's 6 times 2x or 12x dx dt. And again, dx dt is 4. So this is 48x. So at x equal 12, dA dt is 48 times 12, whatever that happens to be. $576. And in terms of, if you want the dimensions, this is in terms of centimeters cubed per second, because it's volume, and areas, this would be centimeters squared per second. Right. Any questions about this? Okay. So this is problem 6. We have the function g of t equals t cubed minus 3t squared plus 5 on the closed interval from -2 to 2. And we want to find the absolute extrema. So we have to find the places where the derivative is 0, calculate the function there, and also calculate the function at the endpoints. So what is the derivative? G prime of t is 3t squared minus 6t. That's 3t times t minus 2, and that's equal to 0 when t is equal to 0 or 2. So these are the critical numbers. So we need to make a little table. For t and g of t. So we have the critical numbers 0 and 2, and also -2, the endpoints. So what is g of 0? G of 0 is 5. G of 2 is 8 minus 12 plus 5. That's 13 minus 12, that's 1. And g of -2 is -8 minus 3 times 4 minus 12 plus 5. That's -20 plus 5, that's -15. So this is the absolute minimum on the interval from -2 to 2, and this is the absolute maximum. The absolute minimum happens to occur at an endpoint, and the absolute maximum occurs at this point in the inside of the interval where you have a critical number. Questions about this? Okay. Problem 7, we have the function f of x equals x squared over x squared minus 9. And we want to find the critical numbers. That means we have to solve f prime of x equals 0. So what is f prime of x? By the quotient rule, it's x squared minus 9 all squared. The derivative of the numerator times the denominator minus the numerator times the derivative of the denominator. Here we have a 2x cubed, and here we have minus 2x cubed, so they cancel. So this is minus 18x. 2 times minus 9 is 18x over x squared minus 9 squared. So you have a critical number where the derivative is 0 or doesn't exist. So the derivative is 0 at x equals 0, and it also doesn't exist where the denominator is 0, which is 3 and minus 3. So those are the critical numbers. Where is the function increasing and decreasing? So we have to look at this function on the intervals between the numbers -3, 0, and 3. Well, this is minus 18x. So when x is positive, this is negative. So f prime of x is negative on both of these intervals. So in these intervals, it's decreasing. And when x is negative, the derivative is positive. So when f of x is increasing on these intervals, and you see you have increasing and then decreasing, so x equals 0 is a relative maximum, because f prime of x is greater than 0 on the interval from -3 less than x less than 0, and f prime of x is less than 0 on the interval x between 0 and 3. I mean, if we try to graph this function, you have vertical asymptotes as -3 and +3. At x equals 0, it takes the value 5. Between 3 and, sorry, at x equals 0, it takes the value -9. And when x is between +3 and -3, this function is negative. So the graph of the function looks like this, between -3 and +3. And here we have these vertical asymptotes. When x is bigger than 3, this is positive, and the graph of the function looks like that. So it's increasing, increasing, relative max, decreasing, decreasing. And here we have these vertical asymptotes. So there are two intervals, this interval and this interval, where the function is increasing, and the two intervals where the function is decreasing. And you can actually sketch the graph of the function. This is what it looks like. Okay. Any questions about this? So problem 8, we have the function f of x equals 4 over x squared plus 1. And we want to find where is this function concave up, where is it concave down, and where it has inflection points. So we want to find the intervals where the function is concave up and concave down. And we want to find the inflection points. So when we study concavity, we need the second derivative. So the first derivative this is 4 over x squared plus 1. So this is, let me see, this is really like 4 times x squared plus 1 to the minus 1. So f prime of x is 4. The derivative of x squared plus 1 to the minus 1 is minus x squared plus 1 to the minus 2 times the derivative of x squared plus 1, which is 2x. So this is minus, I have x squared plus 1 squared in the denominator, minus 8x. That's the first derivative. So the second derivative, minus, I square the denominator, x squared plus 1 to the 4th. The derivative of the numerator is 8 times the denominator, minus the numerator times the derivative of the denominator. And the derivative of this is 2 times x squared plus 1 times the derivative of x squared plus 1, which is 2x. So this is minus something over x squared plus 1 to the 4th. This is 8 x squared plus 1 squared minus 8 times 2 is 16 times 2 is 32. X times x is x squared times x squared plus 1. I can simplify that by factoring out an x squared plus 1. So this is minus 8 times x squared plus 1 minus 32x squared over x squared plus 1 cubed. So what is this? This is 8x squared minus 32x squared. That's minus 24x squared times minus, I can write this as 24x squared plus 8, so it's minus 8 over x squared plus 1 cubed. So if I did this calculation correctly, the second derivative, let me factor out the h just to make it slightly simpler, 3x squared minus 1 over x squared plus 1 cubed. So let me check to see if I've done this correctly. I have the function 4 over x squared plus 1. When I differentiate it, I get something over x squared plus 1 squared, and it is minus 8x. So this is the first derivative. And when I differentiate the first derivative to get the second derivative, put the minus in front of everything, square the denominator, x squared plus 1 to the 4th, the derivative of the numerator, that's 8 times the denominator, minus 8x times the derivative of the denominator, which is 2 times x squared plus 1 times 2x. So I have an 8 here, and I have minus 32x squared times x squared plus 1. And I can factor out an x squared plus 1. And that makes an x squared plus 1 cubed. So I have 8 x squared plus 1 minus 32x squared. 8 minus 32 is minus 24 times minus 1 is plus 24 minus 8. So this is the second derivative, if I was lucky enough to do this correctly. So for this function, f of x equals 4 over x squared plus 1. The first derivative is minus 8x over x squared plus 1 squared. And the second derivative is 8 times 3x squared minus 1 over x squared plus 1 cubed. And let me just make an observation. This is the first derivative. The denominator is always positive. So if x is positive, the first derivative is negative. If x is negative, the first derivative is positive. So f prime of x is increasing, where the first derivative is positive. That means from minus infinity to 0, and not f of x is decreasing, where this is negative, which means where x is positive. So for x from 0 to plus infinity. So just looking at the first derivative, we know this function is increasing, then decreasing. And so there has to be a relative maximum at x equals 0, because that's where it changes from going up to going down. And in fact, f of 0, when you plug in x equals 0, you get 4. So we know this function looks something like this, and it's always positive. Goes up, comes down. So the rough shape of the function y equals f of x is going to have to look like this. But what we're told to look for is concavity. So this second derivative is the function is concave up. F of x is concave up, where the second derivative is positive. Now 8 is positive, x squared plus 1 is always positive. So the second derivative is positive, where 3x squared minus 1 is positive, which means 3x squared is bigger than 1. X squared is bigger than a third. When is x squared bigger than a third? So we have concave up for x from 1 over the square root of 3 to infinity, and from minus infinity to minus 1 over the square root of 3. Right? Because x squared is bigger than 1/3 when the absolute value of x is bigger than 1 over the square root of a third, or 1 over root 3. And f of x is concave down when the second derivative, which is essentially when 3x squared minus 1 is negative, 3x squared less than 1, that means x is less than 1 over the square root of 3 and greater than minus 1 over the square root of 3. So if this is minus 1 over root 3, 0, 1 over root 3, the curve is concave up until you get to that point. Then it's concave down until you get to this point, and then it's concave up again. And so there are inflection points at x equal plus or minus 1 over the square root of 3. So this is a very important type of problem. You have to be sure that you can solve problems like this. Any questions about this? You know, these are all exactly the type of questions that might be on the exam on Wednesday.
Hello? Professor?
Yeah.
Yeah, I didn't get the part that where you were finding f of x increasing or decreasing, and
So this is the function. F of x is 4 over x squared plus 1. So if you differentiate it once, you get minus 8x over x squared plus 1 squared. Okay? So this is the first derivative. Now, x squared plus 1 is always positive. X squared plus 1 squared is always positive. So to know where the function's increasing and decreasing, you need to know when is the derivative positive and when is this negative. So the derivative is positive if x is negative, because it's minus 8x. If x is negative, minus times minus is positive. So from minus infinity to 0, that's where x is negative, the first derivative is positive and the function is increasing. If x is positive, minus x is negative. So the first derivative is negative when x is positive. Positive means between 0 and infinity. So between 0 and infinity, on the interval from 0 to infinity, f of x is decreasing.
so what about the second part?
What about what?
Second part?
Where it's concave up and concave down?
Yes, please.
So you have to calculate the second derivative. And if I did it correctly, this is what it is. This is the second derivative. So the curve is concave up when the second derivative is positive. When is this positive? 8 is always positive. x squared plus 1 cubed is always positive. So the positive or negativeness of this function just depends on the numerator. This is positive when the numerator is positive. 3x squared minus 1 is bigger than 0. That's the same as 3x squared is bigger than 1. X squared is bigger than a third. When is x squared bigger than a third? If x is less than 1 over the square root of a 3, or less than minus 1 over the square root of 3. These are the two intervals where this inequality is satisfied. So from 1 over root 3 to infinity, and minus infinity to minus 1 over root 3, the function is concave up. And when this is negative, this is the function's concave down. Negative means 3x squared minus 1 is less than 0. That means 3x squared is less than 1, or x squared is less than a third, which is this inequality. So that's where it's concave down, from here to here. And the inflection points are where the curve changes from concave up to concave down, or from concave down to concave up. That's the story. Any other questions about this? Okay. Let's go to problem 9. So problem 9 is finding two limits at infinity. So A, or the first one, is the limit as x goes to infinity of 4x minus 1 over the square root of x squared plus x. So you could look at this and say, well, roughly speaking, square root of x squared plus x is dominated by x squared. So this is like the square root of x squared. So this denominator is roughly like x, and the numerator is roughly like 4x, and 4x over x is 4. So you might think that this limit will be equal to 4. So let's just look at this for a second. Let's say I want to factor x out of the numerator and denominator. So 4x minus 1. Let me write this as x squared times 1 plus 1 over x. Because if I multiply, I get x squared plus x. So if x is positive, square root of x squared, this is x times the square root of 1 plus 1 over x. And if I take an x out of the numerator, I get x times 4 minus 1 over x. So the x's cancel. This is 4 minus 1 over x over the square root of 1 plus 1 over x. So what I'm taking, that's just another way of writing this function. So this is the limit as x goes to infinity of 4 minus 1 over x over square root of 1 plus 1 over x. When x goes to infinity, 1 over x goes to 0. So this limit is going to be 4 over the square root of 1. Square root of 1 is 1, and 4 over 1 is 4. So the answer really is 4. That's the limit. Any questions about this? Then the second example is a rational function. The limit as x goes to plus infinity of 5x cubed minus 10x plus 3 over 2x cubed plus x squared minus 9x minus 1. So the rule is, if you remember it, if you have a rational function and the numerator and the denominator are polynomials of the same degree. So in this case, these are polynomials, each of degree 3. Then the limit is going to be the ratio of the leading terms, 5/2. One way to see that is to factor x cubed out of the numerator and denominator. So I get x cubed times 5 minus 10 over x squared plus 3 over x cubed. And when I factor x cubed out of the denominator, I get 2 plus 1 over x minus 9 over x squared minus 1 over x cubed. And the x cubes cancel. And as x goes to infinity, all these expressions with x in the denominator, they all go to 0. And what I'm left with is just 5/2. Any questions about this? Problem 10 is an optimization problem. Find the largest rectangle that can be inscribed in a semicircle of radius 10. So it's not a great drawing, but this is the semicircle of radius 10. And what's the largest rectangle you can inscribe on this? So let's just take a rectangle where one base is the x-axis. If it wasn't, you could just get something bigger by pulling it down to the x-axis. And take a point on the circle, and let's draw the rectangle, which has one of its corners at xy. If that's the case, this point is x0, this point is minus xy, and this point is minus x0. So once you pick a point on the circumference of the semicircle, that determines a rectangle. And we want the biggest rectangle. And if you took a point that wasn't on the semicircle and used that as one vertex of your rectangle, you can make it bigger by stretching this out over to here or up to here. So it's enough just to take points on the circumference. So if you fix a point xy on the semicircle, we have a rectangle. What are the dimensions of the rectangle? The height is y, and the width from minus x to x is 2x. So the area of the rectangle with one vertex at xy is 2xy, the base times the height. And we want to maximize this. This looks like it involves two variables, but of course, y is a function of x. What's the equation of the semicircle? X squared plus y squared equals 10 squared, or 100. That's the equation of the circle of radius 10. So y squared is 10 minus x squared. So y is plus or minus the square root of 10 minus x squared. And if we want the top half of the semicircle as I've drawn it, you take the plus sign. So y is 100 minus y squared is 100 minus x squared. Y is square root of 100 minus x squared. So you take this value for y and you plug it in here. So the area of this rectangle is now just a function of x. It's 2x times the square root of 100 minus x squared. And our problem is to maximize the area. That is to find the x. Once you have x, that determines y. Once you have this side, you reflect it through the x-axis, you get the other side. That determines the rectangle. So the area of the rectangle is just this function of x. What's the derivative? By the product rule, this is 2 times the square root of 100 minus x squared plus 2x. The derivative of the square root of 100 minus x squared is 1 over 2 times the square root of 100 minus x squared times minus 2x. So this is 2 times the square root of 100 minus x squared. This 2 cancels this 2 minus x squared over the square root of 100 minus x squared. If you put this over a common denominator, you get 2 times 100 minus x squared minus 2x squared. So this looks like 200 minus 4x squared over the square root of 100 minus x squared. So let me just check. This is the circle of radius 10. X squared plus y squared equals 100. So y is the square root of 100 minus x squared, and 2xy is 2x times the square root of 100 minus x squared. When you differentiate it, you get 2 times 100 minus x squared plus 2x times the derivative of this, which is minus x over 100 minus x squared. So you get this, put it over a common denominator, 200 minus 4x squared. Yeah. And we want to know, when is this equal to 0? And it's equal to 0 when the numerator is 0. 4x squared equals 200. X squared equals 50. So x is square root of 50, 5 root 2. So you get the derivative equal to 0 just at one point. That has to be a maximum, because as you move from 0 to 1, the area starts at 0, goes up, and then decreases to 0. So this has to be a maximum. And when x is 5 root 2, what is y? Y is the square root of 100 minus x squared, 50, which is again square root of 50, or 5 root 2. So you get the maximum area when x and y both equal 5 root 2. And at that point, the maximum area is 2xy is 25 times 2 is 50 is 100. So the maximum area is going to be 100. So this is the type of problem we did several times in class and in the homework.
Professor,
Yes.
what was the last thing you wrote? I can't really see it. Area
Down here?
equal.
The area, so here's the formula for the area, 2xy. X is 5 root 2, y is 5 root 2, x times y is 50, 2 times 50 is 100. So the
Okay,
dimensions,
thank you.
but the dimensions of the problem says find the dimensions of the triangle. So let me write here, answer This height is 5 root 2. The width is 10 root 2. So those are the dimensions of the rectangle inscribed in the semicircle with maximum area. It's actually something that looks like this. All right. This is problem 11. Which points on the graph of y equals 3 minus x squared? So 3 minus x squared is a parabola opening down. This is 0 when x is plus or minus the square root of 3. That's the parabola. And find the point on the parabola closest to the point 0, 1. So here's the point 0, 1. And if you take any point xy on the parabola, there's some distance d from 0, 1 to xy. And we want to minimize that. We want to find, of all the points on the parabola, I mean, it keeps going, right? I mean, there are lots of points on the parabola. Find the one that's closest to 0, 1. Or by symmetry, there'll always be 2, because if you take the reflection of this point to this point, they're the same distance. So let's say the distance from the point 0, 1 to xy is the distance formula from pre-calculus. It's the square root of x minus 0 squared plus y minus 1 squared. That's the distance formula. And you want to minimize this. So you can make it easier. It's not necessary, but it's just easier algebraically. The square root of something gets smaller when what's under the square root sign gets smaller. So it's enough to minimize x squared plus y minus 1 squared. So let's call that d, because what is y? Y is a function of x. So x squared plus y minus 1 squared, that's x squared plus, what is y? 3 minus x squared minus 1 squared. That's x squared plus 2 minus x squared squared. That's x squared plus 2 minus 4x squared. So square this, x squared plus 4 minus 4x squared plus x to the 4th. That's x to the 4th minus 3x squared plus 4. Okay. So let me just review this, because this is a critical step. Here's the parabola. If you take any point xy on the parabola, the distance between these 2 points, xy and 0, 1, is the square root of the sum of the squares of the differences of the coordinates, x minus 0 squared, y minus 1 squared. Because x minus 0 is just x squared, and y, and you get the square root is smallest when what's underneath is smallest. So we can minimize the algebra by just looking at this expression, x squared plus y minus 1 squared. And we want to minimize this. We want to make this as small as possible. And we use the fact that y is 3 minus x squared. plug that in for y. So x squared plus y minus 1 squared is x squared plus 3 minus x squared minus 1, which is 2 minus x squared. And when you square this, you get 4 minus 4x squared plus x to the 4th, which is this. So as a function of x, the distance of the point xy to 0, 1 is given by this. What's the derivative? 4x cubed minus 6x. Let's see, if I factor out 4x, I get x squared minus 3/2. And this is equal to 0 when x is either 0 or plus or minus square root of 3/2. What's the second derivative? 12x squared minus 6. If you evaluate the second derivative at 0, you get minus 6. If the second derivative is negative, you have a local max, but we want a min. Suppose we evaluate the second derivative at plus or minus square root of 3/2. That's 12 times 3/2 minus 6. That's 18. That's 12. That's positive. So x equal plus or minus square root of 3/2. These give you the local minima or relative minima. And when x is plus or minus square root of 3/2, y, which is 3 minus x squared, is 3 minus 3/2 is 3/2. So you have the points, the 2 points on the parabola closest to 0, 1 are at x equal √3/2. Y equals 3/2, or x equals minus √3/2, y equals 3/2. So that's the answer. Okay. Questions about this?
I'm confused.
Sorry, is there a question?
Yes. Hello?
Yeah.
Yeah, I'm confused.
All right. Confused about what part?
The second part where you were calculating the x and y.
Okay. So let me just review it carefully. So we have this is the parabola y equals 3 minus x squared. That's 3. And here we have the point 0, 1. And if we take a point on the parabola xy, I want to find xy so that the distance from xy to 0, 1 is as small as possible. So you get this distance. In fact, I'll just take the distance squared so I can get rid of the square root. This is x minus 0 squared plus y minus 1 squared, right? You take the difference of the coordinates squared and add. So that's x squared plus y minus 1 squared. But y is 3 minus x squared, so that's x squared plus 3 minus x squared minus 1 squared. And 3 minus 1 is 2. And 2 minus x squared squared is 4 minus 2x squared plus x to the fourth. So this is x to the fourth. That's a 4. Minus 3x squared plus 4. So this is the function I want to minimize.
Yes.
And okay. So this is the first step. To get the function, you have to minimize. And it took a certain amount of reasoning to get from the statement of the problem to this. And you look for your relative minima and maxima occur where the derivative is 0. So for this function, just a polynomial, you differentiate it, you get 4x cubed minus 6x, which is 4x times x squared minus 3/2. So that equals 0 when either x is 0 or x squared is 3/2, which means x is plus or minus square root of 3/2. And then you have the second derivative, which is 12x squared minus 6. And the second derivative at either plus or minus 3/2 is positive. So x squared, x equal plus or minus 3/2 is a minimum. And when x is plus or minus 3/2, what is y? Y, remember, is 3 minus x squared. So that's 3 minus plus or minus 3/2 squared. That's 3 minus 3/2, which is plus 3/2. So we get the following points on the parabola. Square root of 3 over 2, comma 3 over 2, and minus root 3 over 2, comma 3 over 2. And these are the 2 points on the parabola closest to the point 0, 1.
Got it. Thank you.
So again, it's things get more sophisticated and technical as you learn more and more calculus. So there's a lot that goes into solving this problem. Okay, the last problem is number 12. Find positive numbers x and y that satisfy the equation, the sum is equal to 12. And of all the pairs of numbers that add up to 12, and the product is a maximum. So for example, if you take x equal 1 and y equal 11, x plus y is 1 plus 11 is 12, and x times y is 1 times 11 is 11. Or if you take x equal to 2 and y equals 10, x plus y is 2 plus 10 is 12, and x times y is 2 times 10 is 20, which is bigger. So you want to find what pair of positive numbers add up to 12 and maximize the product. So again, what we want to maximize is this product x times y. Subject to the condition that x plus y is 12, which means once you have x, y is determined. Y has to be 12 minus x. So xy is really x times 12 minus x, which is 12x minus x squared. So to find the x in this problem, we want to maximize the function f of x equals 12x minus x squared. Of course, this is actually a parabola going down, so you know there is going to be a maximum. But usually the way you find a maximum is by differentiating and setting the derivative equal to 0. So if this is f prime of x, if this is f of x, f prime of x is 12 minus 2x, and that's equal to 0 when x is equal to 6. And when x is equal to 6, 12 minus 6 is 6. Y is equal to 6. So the answer is x equal y equals 6. Because x plus y is 6 plus 6 is 12. And x times y is 6 times 6 is 36. And that's the largest product of two numbers that add up to 12. Right? So you get the maximum value of 36 when you choose x equal y equals 12. And that's what it is. Any questions about this? So I posted the review sheet on Blackboard. I also posted the solutions on Blackboard. Of course, this is recorded, so this will be posted on YouTube. The test is on Wednesday, exam 2. I will schedule kind of like a time tomorrow when I'm on Zoom. If you have any last minute questions, I'm not available in the middle of the day tomorrow, but I will try to schedule a Zoom session very late in the afternoon. I should be available by, I hope by 4:30 or 5. But I'll send out an email with the same Zoom login, but the Zoom time, and it's like office hours. So if you have any questions, I'll be online and you can just log in and ask whatever questions you might have before the exam. The exam itself is just like the first exam in the sense that I'll post it on the assignment section on Blackboard under exam 2, also email it to you. You write out your solutions, convert to a PDF file, and then upload it to Blackboard by 3 o'clock.
How many questions, please?
Sorry?
How many questions?
It'll be similar to the last exam. I'm not sure exactly, but also it will include some extra credit questions, just like the last exam did. So.
Less than 10.
Sorry?
Less than 10 questions.
Yeah, you know, approximately, but again, until I haven't made up the exam, so I can't tell you precisely. But it's not going to be, it'll be similar to the first exam in terms of the number of questions, you know, plus or minus 1 or 2. Open book exam.
2 hours, right?
2 hours from 1 to 3.
Thank you.
All right, well, if there's nothing else, looks like a beautiful day. So, exam on Wednesday. And I'll be online on Zoom during most of the exam if there are any technical questions you have about something. I'll be available. And if I'm not available on Zoom at that instant, if you send me an email, I'll get back to you. Okay, everyone. Study hard, do well. Exam on Wednesday. Review tomorrow, late afternoon. Bye, everyone.
Very good one, Professor.
Thank you.